So think about any time you've, used a website, you've clicked a button to submit something, maybe a query, or you've signed up for a new service, loaded a dashboard that's completely personalized to you.
Right.
In that moment, you're basically participating in, well, a moment of digital trust. You send your information out into the void.
Yeah, and you just hope for the best.
Exactly. And something invisible, this engine, keeps the promise of what's supposed to happen next.
And that invisible engine, the part that gets that input, processes the request and makes sure your data is saved securely.
Mm.
Oh. Well, that is the world of back-end development.
The engine room.
That's the engine room we are diving into today.
Okay, so let's unpack this for someone who's already a bit familiar but wants to get to the next level. Our mission today is pretty clear.
Yeah.
We want to shortcut that traditional long learning curve of back-end development. We're going to dissect the big pieces, servers, databases, application logic, but we're going to focus really squarely on how these new, modern, free AI-assisted tools have just completely changed the game.
They really have.
In terms of accessibility and, speed.
This isn't just a theory session, right? This is the practical guide. We're drawing from sources that have this, coaching mindset. So we're moving past just defining the parts.
Right.
And we're getting into how you actually connect them using platforms like, say, Firebase or Supabase. The goal here is really to empower you to master that invisible half of web development.
Turning complexity into something manageable.
Into manageable, even automated steps.
I think that shift is the key, isn't it? The move from all that manual configuration to, prompt-based architecture.
It's a huge shift.
We want to transition you, the listener, from being just a consumer of web services to becoming an empowered architect of them. So let's start by really defining that architecture itself. We spend so much time, and rightly so, admiring the front end. The slick design, the fast load times, that smooth user experience.
Of course, that's the face of the application. It's what people see.
But what is the back end's fundamental role? I mean, beyond just existing, what is its actual job?
Its central function, and our source material puts this beautifully, is keeping the promise.
Keeping the promise. I like that.
Yeah. The front end shows you a button that says create account. The back end is the entire infrastructure, everything dedicated to actually fulfilling that promise.
So creating the record, storing the password.
Storing the password securely, verifying the email, getting that welcome message ready. The back end is really the heart of the site. It's unseen, it's steady, and it's absolutely essential for any kind of real interaction or persistence.
That word persistence is so important because if the back end fails, the promise is broken.
And trust is gone instantly.
So let's take a common scenario, a simple contact form. You click submit. We know there are a few major steps that happen behind the scenes. Let's really detail that sequence, that kind of choreography of data.
Okay, yeah. This workflow is basically foundational to any interactive web system.
So what's step one?
Step one is the back end receives the data. The server just acknowledges the incoming request from the browser. It says, okay, I've got this package of information. A name, an email, a message.
Just confirms the connection.
That initial receipt just confirms, yes, we are connected and I've got the package.
Okay, so once the data is received, it moves into what, the engine room, the logic part.
Exactly. Step two is processing the data.
Yeah.
This is where the application logic, the rules, kick in. For a contact form, the logic is probably pretty simple.
Right.
Validate the email format, sanitize the message so no malicious code gets in, and then get it ready for storage. But in a more complex app, this step could be, calculating invoices or checking inventory.
And that validation and sanitization part you mentioned, that's a security layer, right? It happens before anything gets stored.
Absolutely. It's crucial. Then you get to step three, which is the memory component. The back end stores the process information in a database. This is the difference between a sticky note and a permanent filed record. The data gets written to a structured location, so it survives a server restart, a power outage.
And it can be pulled up later when the admin needs it.
Precisely.
Yeah.
And then finally, you have to close the loop with a user.
Right. You can't just leave them hanging.
No. So step four is the conclusion. The back end sends a reply or updates a confirmation screen. It sends something back to the user's browser. This is that positive feedback, the thank you message, or the redirect.
So the back end is the one telling the front end, hey, promise kept.
Promise kept, job done.
Yeah.
This whole loop receive, process, store, reply, That is the absolute minimum you need for any real persistent interaction on the web.
That makes it so clear. The back end isn't passive at all, it's an active participant. Now, to help structure this, the sources use this great analogy of a digital restaurant. Let's use that to break down the three essential back end building blocks.
Yeah, this is a fantastic way to think about it because it gives each layer a really clear job.
Okay, so what's first?
First up, we have the server. Its role is all about handling requests and sending responses. It's the gatekeeper, the messenger.
Yeah.
So in our analogy, the server is the waiter taking the orders.
The waiter.
The waiter connects with the customer, that's the user's browser, and carries their specific request back to the kitchen, the execution area.
So if a user wants to load the homepage, the server is the one that gets the request for the HTML file and then brings it back. It's basically traffic management.
Exactly. Which brings us to the second block, the database. Its job is simple: storing, retrieving, and organizing information.
If the server is the waiter.
Then the database is the kitchen pantry.
Ah, okay.
It holds all the critical ingredients, all the user accounts, the product lists, the messages, and it keeps them organized so they can be grabbed really, really quickly.
And the pantry doesn't, analyze the data or decide what to cook with it. It's just pure index storage.
Correct. Which leads us to the third and honestly the most crucial layer, the application logic. This is where the rules are, the algorithms, the decision-making intelligence of the whole system. This is the chef following the recipe.
I see. So the chef gets the order from the waiter.
Right. The chef gets the request from the server, retrieves the ingredients, the data from the pantry, from the database, executes the steps, processes the logic, and then tells the waiter what to take back to the customer as the final product.
I think connecting those analogies to their technical parts is what really makes this click. We're talking about the server using HTTP, the database using a language like SQL, and the logic being, custom-written code.
Right.
It makes that invisible power feel less like some black box and more like a system, a process.
And if you look at the bigger picture, the seamless interaction between these three, the server handling the request, the logic making the decision, and the database providing the memory, that's what determines the ultimate performance, the reliability, the scalability of your entire application. If the chef is slow or the pantry's a mess, the whole restaurant grinds to a halt.
All right, so we have the building blocks. Let's go a level deeper on the server and the database, especially with how modern tools have, hidden a lot of the complexity. When we say server today, we're not usually talking about a physical machine with blinking lights in a closet anymore, are we?
Oh, absolutely not. I mean, at its core, a server is still just a computer waiting for instructions.
That's harsh.
That's true. And the basic request-response cycle is still the same.
Right.
Your browser sends a request, a GT request for the homepage, and the server finds it and sends it back. That part is universal.
But the big shift is in the infrastructure. This is where the cloud comes in. We're talking about serverless, edge computing, managed platforms.
This is where the barrier to entry just crumbled. It's the complete elimination of the infrastructure headache. Platforms like Vercel or Netlify or Firebase hosting, they manage everything.
Everything meaning what? Scaling.
Automatic scaling, global content delivery network CDNs. For you, the learner, this means you just deploy your code, your application logic, and the cloud provider worries about all the hardware, the maintenance, what happens when you get a huge spike in traffic.
Even where to physically put the servers for the best speed.
Exactly. You don't need to think about cables or cooling.
And that's a huge win, not just logistically, but financially for a beginner. You're not paying for a machine that's just sitting there idle. You only pay for the computation when someone actually uses your site.
Right. This move to serverless is so important. It abstracts away all those physical limits. You can deploy an API endpoint, and it's automatically distributed across the globe. So if someone in Tokyo hits your site,
they're being served from a data center nearby, not one in, say, Virginia.
And that dramatically improves the speed, the latency. We say the headache is eliminated, but the real benefit is getting instantaneous global scalability right out of the box. That used to take a massive team of engineers.
Okay, that completely changes the game. So if the server part is handled by these AI-powered platforms, let's talk about the storage, the database. We said it's like a digital notebook, an organized collection of info. But for our audience, we need to move past just tables and rows.
Agreed. We can assume everyone understands tables, columns, rows. What's more critical now is understanding the type of organization. Most web apps still use structured data in tables, but we have to talk about the big split. relational versus document databases.
Okay, let's use our examples to illustrate this. You mentioned Supabase, which uses Postgres. That's relational, right?
That's right. And Firebase uses Firestore, which is a NoSQL document store.
So what is the core difference that a developer needs to get?
It's all about how relationships in the data are handled. In a relational database, like in Supabase, the data is highly structured. The relationships between tables are strictly enforced.
How so?
Well, if you have a users table and an orders table, the system makes sure that every single order is linked to a valid user. It enforces that connection. This is fantastic for things with high complexity, like financial transactions, where data integrity is paramount.
And the document model, like Firebase, what's the trade-off there?
Document databases give you flexibility. The data is stored in these JSON-like documents, often nested inside each other. They're amazing for rapid prototyping, for real-time updates, and for handling data that doesn't fit neatly into a grid.
Like a complex user profile with lots of different fields.
Or blog comments, things like that. The trade-off is often slightly looser data integrity compared to the rigid structure of SQL. So the choice really depends on what you need. Do you need rock-solid integrity for finance, or do you need flexibility for content?
Let's anchor this with a more complex example than just a contact list.
Okay, think about a streaming service. You've got multiple tables. They need a catalog table, right? With columns for title, director, genre. Then they need a user watch list table, user ID, movie ID, a timestamp, and of course a billing table, user ID, subscription tier, payment date.
And these tables are all connected and need to be fast.
Super fast, which is why they all rely on indexing. Indexing is a crucial back-end concept. It's like the index in the back of a textbook. It tells the database engine exactly where to look for data so it doesn't have to scan every single row. That's how you get those near instantaneous search results we all expect.
And the incredible part, the real takeaway here, is how AI has changed this. I mean, designing an optimized database schema, managing indexes, that was a very specialized job.
Yes, it was the exclusive domain of database administrators, or DBAs. But the AI integration is the great equalizer. Instead of spending hours reading documentation on data types or query optimization,
You just describe what you need.
you describe it in plain English. You can prompt the AI, and it will design a schema, it will suggest the right data types, and it might even propose the best indexes you'll need for speed. It frees you up to focus on the logic, not the plumbing.
And that leads us right into the specific tools we can use to start building. The fact that these have generous free tiers and AI assistance means they're not just toys, these are production ready.
Absolutely.
So let's compare the major players mentioned in the sources.
Yeah, this is important because the choice really matters. Each tool is kind of aimed at a slightly different use case.
Let's start with the big one, Firebase.
Okay, so Firebase is Google's all-in-one platform. Its main strength, its killer feature, is its real-time database capability. It is phenomenal for any system where users need instant updates.
Like a chat app or a collaborative document editor.
Exactly, or live dashboards. But beyond the real-time stuff, what makes it so good for beginners is that it's a batteries-included solution.
What do you mean by that?
It combines the three core back-end pieces into one seamless platform. You get the real-time database, which is Firestore. You get Firebase hosting for the server part. And you get robust Firebase authentication.
So you can build and deploy a whole app with user logins and everything without ever leaving the Firebase ecosystem.
Precisely. The one thing to remember is that it's a NoSQL document database. So managing really complex, multi-layered data relationships can sometimes be a bit more challenging than in a traditional SQL system. You're trading some of that rigidity for speed and real-time power.
Got it. Okay, now let's look at its main competitor in this modern space, Supabase. You called this the relational open source hero.
Yeah, Supabase is getting huge traction, and for good reason. It gives you the power and maturity of PostgreSQL, which is really the gold standard for relational databases, but it's wrapped in this incredibly modern, easy-to-use developer experience.
And the open source part is a big deal for a lot of people.
It's a huge plus. It means you're not locked into a single vendor. You have long-term control over your stack.
But the real game changer, especially for learners, is the AI assistance. How does that conversational query feature change how we interact with SQL?
It basically solves the syntax problem. SQL is an incredibly powerful language, but you have to be so precise.
One missing comma and the whole thing breaks.
Exactly. So if you need to write a query to, say, find the average order value for all users who signed up in the last quarter and have made at least 3 purchases, that's That's a complex query to write from scratch.
For sure.
With Supabase AI, you just type that natural language prompt. The AI translates it into optimized SQL code for you. It's a massive accelerator for building complex reports and features without needing a PhD in PostgreSQL.
So you get the power and data integrity of a relational database, but with a much lower barrier to entry for querying it.
Exactly. So if I was
Yeah.
building a financial app and I really prioritize data integrity, Supabase would be a very strong contender.
Okay, let's pivot now. Let's go completely to the no-code side of things with Airtable and Softar. This is a really interesting combo.
Yeah, this pairing shows that you don't even need to know traditional coding to build a powerful backend.
So how does this work? How does what looks like a fancy spreadsheet become a functioning backend?
Well, Airtable acts as your database. It's a very visual, user-friendly take on a relational system. You have fields and records, but you manage it all through a spreadsheet-like interface.
And Softar is the front-end builder.
Softar is the presentation layer. It connects securely to your Airtable base using an API. Softar handles the user interface, the user authentication, and all the logic for fetching data from Airtable and displaying it.
So this would be great for things like internal tools, maybe a company directory, or a simple marketplace.
This is perfect for that. Low to medium traffic applications where you really value being able to iterate quickly and manage things visually. You're trading ultimate performance for incredible speed of deployment and clarity. It's proof that you can keep that back-end promise with 0 lines of traditional code.
And finally, there's Replit database. The sources highlight this specifically for practice tasks. Why?
Replit DB is designed for simple key-value storage. Think of it like a super-fast dictionary that lives in the cloud.
Right.
It's made for frictionless, temporary, or very simple persistence. If you're just learning how to save a variable, like a user's preferred theme color, or a simple high score in a game Replit, it's perfect because the setup is literally instantaneous.
So it keeps the cognitive load really low.
Exactly. It lets you focus purely on the concepts of storage and retrieval without worrying about configuration files or schema design. It's the ideal sandbox for learning the absolute basics of persistent storage.
The lesson here seems clear. The AI has kind of eliminated that blank page syndrome you get with architecture, and the free tiers let you start building real scalable systems today, not tomorrow.
Yeah.
Okay, so we have our components, we have our tools. Now we need the plumbing. The system that lets the front end and the back end actually talk to each other. We called it the bridge. Let's talk about the API bridge.
The API, the application programming interface.
Yeah.
So if we go back to our waiter analogy, the API is the set of standardized rules for ordering food.
The menu, almost.
Kind of like the menu and the language you use. A customer, the front end, can't just yell into the kitchen, the back end. They have to use the waiter and follow the established format.
And in web development, that format is usually based on REST principles, which means the API is structured around specific actions.
Right. Actions mapped to HTTC methods. Things like get, post, put, delete.
So the API defines these endpoints, which are like digital addresses for specific tasks.
Exactly. The front end sends a request to a specific endpoint, like users, and uses a method like ppost to signal that it wants to create a new user. The API gets that instruction and kicks off the logic.
And what's so cool now is that we don't have to manually write all the boilerplate code for these endpoints anymore. The sources really stress this AI code generation.
This is a huge time saver. Before, setting up an endpoint meant defining the route, handling how to parse the incoming data, writing error handling.
Yeah.
It was a lot of repetitive work.
Right.
Now, you just prompt the AI with what you need. Create an API endpoint to save contact form data and make sure the email field is present. The AI just generates the secure, structured code for that function.
The source gave us a little JavaScript code snippet that really shows how clear this generated logic can be. It was app.post, contact, rest save the database, rec.body, rest.send, thank you.
Mm-hmm.
Let's just break down what that tiny piece of code is actually doing in terms of our whole back-end workflow.
Okay, so that snippet is the essence of the chef's recipe for that contact form. First, app.post contact. This defines the route. It tells the server, our waiter, to listen for a post request, meaning new data is coming in at the digital address contact.
Okay.
Then, save the database, rec.body. This is the logic and storage step. Rec.body is the raw data, the name, email, message. The chef uses this instruction to run the database storage function.
And the last part is the reply.
Rest.send, thank you. That's the reply. The server sends that confirmation back to the user's browser.
It really distills what used to be complex server-side scripting into these super readable functional chunks.
It does, and it reinforces that idea that APIs are like people using a common language. They make sure different applications, a front end in Vue, a back end in Node.js, can all communicate predictably because they follow the same rules.
Predictability is so important.
It's key, especially when you start linking multiple services together.
Okay, so once that connection is solid, we have to talk about the foundation of any digital relationship: trust and authentication. If the backend is going to remember a user, it needs to be sure who that user is.
Right. Authentication is confirming identity. It's the bouncer at the digital door, checking the user's ID. It covers everything from the initial login and sign up to password resets to managing their session.
And historically, this is where so many security vulnerabilities came from. I mean, password hashing, managing tokens like JWTs, dealing with session timeouts. It's all very technical and easy to mess up.
Oh, it's incredibly error-prone. And that is why the AI automation in this space is so revolutionary. Building a secure auth system is hard. Building a secure and scalable one is even harder. And now, frameworks like Supabase Auth, Firebase Auth, or even dedicated services like Clerk AI, they generate the entire secure authentication pipeline for you automatically. They handle the password hashing, the token generation, the session verification, everything you need to keep the system robust.
So a beginner can deploy what is essentially enterprise-level security protocols instantly just by installing a module.
It completely democratizes security. And the core value our sources stress is that privacy builds trust faster than features. The backend's #1 job is data protection. If your authentication is flawed, nothing else matters. The database, the logic, the cool features, it's all irrelevant because the user's private data is at risk.
Always protect user data.
Always. It's the single most important part of keeping a positive long-term relationship with your customer.
Theory is one thing, but we need to see this in practice. Let's focus on that very first step for any backend project: AI for database design. Taking an idea and turning it into a real structure.
Right. This moves database design from being this long architectural planning phase into more of a conversational phase. Let's use that specific prompt example from the sources.
Okay, the goal was to create a structured record system for students. And the prompt was, create a database for student records with fields: name, class, marks, email. Ensure marks is an integer, and the combination of name and class must be unique. That last part, that constraint, seems really important for data integrity.
It's a fantastic prompt because it specifies both the structure and a business rule, a constraint. So the AI will instantly produce the optimized schema. It'll define the table, it'll pick the right data types, varchar for name, integer for marks, and crucially, it will define what's called a composite unique constraint on the name and class columns.
Which means what exactly?
It means the database just won't accept 2 entries for John Doe in Math 101. It prevents duplicate records.
And it completely bypasses the need for the learner to go look up the exact SQL syntax for creating that composite constraint.
It does, and it often goes further. It won't just produce the schema. It'll often suggest some sample data so you can see what it looks like. And it might even propose creating indexes on columns you're likely to search often, like email or name, to make it faster.
That instant feedback on the design is so powerful.
It's incredibly empowering.
Okay, let's make this even more concrete. Let's walk through a complete end-to-end task: the classic newsletter signup. It's simple, but it uses every single component we've talked about.
This is the perfect practical flow. So step 1, user fills the form.
That's the front end. The user types their email, clicks the button.
Step 2, front end sends data to the AI-generated API. The browser, using JavaScript, packs up that email address and sends it as a POST request to our signup endpoint. That's the waiter passing the order ticket to the kitchen. Step 3, backend processes and saves the data. The logic validates the email format, sanitizes it, and then runs the command to insert that new record into the database table. The chef is storing the new ingredient in the pantry.
And then the final step to close the loop.
Step 4, a success message returns. The backend confirms the data was written successfully and sends a 200 OK status back to the front end, which then shows the confirmation sent message to the user.
And the real efficiency game here is that an AI can write the code for all of the back-end parts of that in minutes.
All of it. The API definition, the storage function with basic error checking, and the response handler. What used to be hours of development is now compressed into a few prompts.
To bring this home, the source material gives us this great little story about Bilal from Rawalpindi. It's an anecdote that just perfectly illustrates the impact of this compressed timeline.
Yeah, Bilal was given a project to build an internal system for his university, a smart feedback form for teachers to quickly log issues or suggestions. So he needed a database, secure connection, an API, the whole 9 yards.
In a traditional world, that project means getting a server, installing a database, setting up credentials, manually coding the API logic. It's a lot of
A
steps.
lot of steps. But Bilal just sidestepped all of it. He used the AI capabilities of his chosen platform, which was Supabase AI.
So what did he do?
First, he just prompted the AI to design his feedback table, telling it what fields he needed, like issue category, severity, submission date. Then he prompted the AI again, asking it to generate the JavaScript API code that was specifically designed to save data into that new Supabase table.
And what was the total time from idea to a working system?
The whole thing, including hooking it up to a simple front end, was functional and deployed in just one evening.
One evening.
He had a system that was storing real, persistent data in a secure, scalable cloud database in a matter of hours.
The teacher's comment is what gets me. You did what our IT team planned for next semester. Staggering, isn't it? It just shows how much the value proposition has shifted. The bottleneck isn't the rote work of coding the plumbing anymore. The bottleneck is defining the problem and designing the experience.
Which is where it should be.
Right. And the coach's insight here is so true. Real learning happens when you build something useful for other people. And these AI tools have just dramatically lowered the barrier to building something genuinely useful.
Building fast is one thing, but building securely and reliably is just non-negotiable, especially if you're keeping that promise of data persistence. So we have to talk about the critical next steps: security, testing, and automation. You don't have to be a cybersecurity expert, but there are some rules you just have to follow.
These are the core rules for digital hygiene. The 5 essential security basics for any beginner. Rule number 1 is simple. Never display raw user data on the screen.
What does that mean in practice? It primarily applies to sensitive stuff like your API keys, raw password hashes, or session tokens. These values should never, ever make it to the front end. If they're visible in the browser, you're exposing the keys to your kingdom.
Okay. Rule 2 is about the connection itself.
Use HTTPS. This is not optional anymore. HTTPS ensures the data traveling between the user's browser and your server is encrypted. It's scrambled.
And without it,
Without it, you're using HTTP, and the data travels in plain text. It makes it trivial for a bad actor to intercept sensitive information. Thankfully, platforms like Vercel and Firebase give you free, automatic HTTPS, so there's no excuse.
Rule 3 is about protecting those digital keys.
Keep your API keys private. Any key that gives special access to your database or other services must live only on your secure back-end server. Never hard-code it into your front-end code.
Because anyone can just view the source code of a website.
Anyone can view the source, grab the key, and then potentially access or just delete your entire database.
Wow. Okay, what about preparing for failure?
That's Rule 4. Back up your database weekly. Even in the cloud, redundancy is key. Human error happens. Accidental deletions, code bugs, they can corrupt your data. Having a weekly snapshot, a backup of your kitchen pantry, ensures you can restore your app if the worst happens.
And the final rule is about just cleaning up.
Yep. Delete unused accounts and test data. Every piece of unneeded data or dormant account is a potential liability. If a hacker gets into an old, unused test account, that could be their way into your system. So delete test data, remove old accounts, keep your data footprint clean.
The simple takeaway is clear.
Protect data like you protect your own ID card.
That's a great rule of thumb. So once we're secure, we have to make sure the logic actually works. We need to get into testing your backend. If the AI wrote the code, can't we just trust it?
We can trust the AI for syntax and basic structure, sure, but we can't trust it to understand your specific business logic or how it integrates with other systems.
Right.
Testing verifies that the whole data flow works in your specific context. Did the payment processor actually get the right amount? Did the confirmation email send after the database write was successful? These are crucial integration points.
And how does AI help with what can be a really tedious testing process?
AI can simulate actions and generate test data for you. So instead of spending an hour manually typing in edge cases, like what if I use a weird character in a name field or a super long message, you can just prompt the AI to simulate those actions and check the response.
So it can help with both small tests and the whole end-to-end flow.
Absolutely. It helps with unit testing individual functions and with integration testing the entire flow.
And what are the free tools available for this?
You need tools that let you talk to your API directly without the front end. Postman AI is the industry standard. It lets you send test requests to your API and inspect the data and status codes that come back. Hopscotch is a great lightweight open source alternative.
And the platforms themselves have tools too, right?
For sure. The Firebase console or the Supabase dashboard give you that final visual confirmation that yes, the data arrives safely in the pantry and it's structured correctly.
And we have to remember the coach's motivational tip here.
Oh yeah. If something breaks, don't panic. Debugging is learning in disguise. A bug isn't a failure, it's just a clue about how your system really works.
I love that. Failure is just a detailed data point.
Exactly. And finally, let's talk about the next level of back-end mastery, automation and webhooks. This is about making your back-end work even harder by connecting it to other systems.
The magic connectors that turn data storage into automated action.
That's a good way to put it. A webhook is basically just an automated notification. It's a way for your back-end to shout, hey, something just happened over here, to another application.
For example,
When a new user signs up, that's the trigger. Your database sends a webhook notification to your email marketing service, which is the action.
and what are the tools for setting up these connections?
Services like Make, which used to be Integromat or Zapier, they specialize in being that connective tissue between hundreds of different APIs. They let you build these complex multi-step workflows without writing any custom integration code.
So let's use the example from the source. When a new record is added to my Airtable, send a Gmail notification. How does AI speed that up?
In the past, you'd have to manually connect and authenticate both Airtable and Gmail, then write the logic to map the fields from the new record into the email body. Now, you just state that prompt to Make or Zapier. The AI handles the whole setup.
Seriously?
It authenticates with Airtable, it watches for the trigger, connects the Gmail API, and it formats the email based on the data from the new record. It instantly turns a simple database entry into this cascade of automated actions. It maximizes the value of the data you're saving.
That shows the real power of back-end knowledge, doesn't it? It's not just about storage. It's about creating intelligent, interconnected systems that respond automatically to events. Hashtag outro. Wow. We've gone on a pretty comprehensive journey today, all the way from the conceptual digital restaurant to the very practical application of tools like Supabase and Firebase.
We really have. Let's just summarize those core lessons one
Yeah.
last time, focusing on the simple takeaways.
Okay.
The back end is the engine. It runs your website, and it keeps your promise.
Right.
The database is where all your organized information lives. It's the memory. The API is that standardized bridge that lets all your different systems talk to each other reliably.
And authentication is how you confirm identity and build that crucial trust.
And the essential AI toolkit Firebase, Supabase, Airtable, Replit makes all of this accessible to you right now.
And we can't forget the safety reminder. Never expose your API keys, always use HTTPS, and
Protect data like you protect your own ID card.
mastering this invisible half of development really is the prerequisite for building a true full-stack system, isn't it? Connecting that visible interface with the persistent memory.
It is. And that leads us to that final synthesized insight from the coach on the front end versus back end relationship. The front end introduces you to the world, but the back end remembers you tomorrow and keeps relationships alive.
That is such a profound distinction, attraction versus memory. And if the back end is the memory, and you now have this unprecedented AI-driven power to structure that memory, well, we want to leave you with this final thought.
Yeah.
What kind of relationship do you want your website to sustain? If your back end is your system's intelligence, what knowledge are you going to choose to preserve? And how will that store data, those specific rows and columns you design? How will that shape the future experience for every one of your users?
Because the decisions you make about your database schema, they're not just technical decisions, they're narrative decisions. They dictate the history and the future of your platform. So choose your memory wisely and build your engine strong. Until the next deep dive, keep experimenting, keep learning.